Let's now take a look at the propagation of an action potential in a neuron after it arises at the trigger zone. Action potentials propagate down an axon. That is, they don't lose their strength like graded potentials do. And the way this happens is that when sodium ions flow in and cause depolarization, that flowing in of those ions causes voltage-gated sodium channels in adjacent segments of the axon's membrane to open, and then it just keeps moving on down the length of the axon. There are two kinds of conduction that occur down an axon. One is called continuous conduction, and the other is called saltatory conduction, and we'll look at the difference between these two in the next two slides. Continuous conduction is a step-by-step depolarization of each portion of the length of the plasma membrane of the axon. This type of conduction occurs in unmyelinated axons, and it is slower than saltatory conduction. Saltatory conduction, on the other hand, involves a depolarization only at the nodes of Ranvier, where there's a high density of voltage-gated ion channels. The current carried by those ions flows through the extracellular fluid and through the cytosol from node to node. And in contrast to continuous conduction, this kind of conduction involves the action potential moving faster than it does for continuous conduction.